Solve another Leetcode problem, 3180, maximum total rewarding. So it is the maximum total reward using operations 1. So for this kind of operation, it is just coming from here. So this x is going to equal to x plus the reward values I. Yeah. So this is the operation. So if the reward values I is greater than the current total value x, then we can use this kind of operation. Let me just do a simulation to just try to understand what's going to be the problem. Yeah. So for example, we have array like 1, 1, 3, and 3. What are we going to do? We're going to take the first number, this 1. So we're going to accumulate a total sum. It's going to be 1. And next, we're going to choose the next number. Can we choose this 1? We cannot, because the next value, this 1, must be more than the total sum, this 1, but it is not. Now, can we choose this 3? Yes, we can, because 3 is more than 1. So we're going to choose this 3, because 3 is more than 1. So 1 plus 3 is going to be 4. Now, we're going to try to choose the next value. It is 3. 3 is not possible, because 3 is not more than 4. Maybe there's another value 5. Yeah. So 5 is going to be more than 4. So this means we're going to choose this value 5. So this means 4 plus 5 is going to be 9. So in this case, we're going to return 9. In our example, we're going to return 4. Now let's just check the second example. So for the second example, we have some random numbers like 1, 6, 4, 3, and 2. But yeah, we can choose the numbers randomly, but we can only choose once. We can only choose one time. But as the question said, so for the next number, it must be more than the previous, the total sum of the previous numbers. Yeah. So this means we can sort the array. So we're gonna sort it like for this example. So 1, 2, 3, 4, and 6. So this is a kind of a greedy idea. But for our problem, we're gonna use a 0, 1 knapsack. So first of all, we're going to sort the array, and now we're going to use the 0, 1 knapsack to solve the problem. So for the first number, we're going to decide, can we choose the first one? Yes, we can. Can we choose the second one? Yes, we can, because 2 is more than 1. And currently, the total sum is 3. Can we choose this 3? No, we cannot. Can we choose this 4? Yes, we can. So 3 plus 4. So 3 plus 4 is going to be 7. Yeah, but this is not the maximum, right? So what about we choose another way? Maybe we will not choose 4. What about 6? But 3 plus 6 is 9. It's not the maximum. Maybe we're going to choose another way. Let's also try another way. Maybe we can find a maximum, because basically this is a 0, 1 knapsack. Yeah. So currently we're going to choose the first number, this one. And then we're going to choose this number 4, because 4 is more than 1. Currently the total sum is 5. And 6 is more than 5. It is okay. So 5 plus 6 is going to be 11. So 11 is going to be our answer, and it's going to be the maximum number. Now we're going to use this kind of idea to solve the problem. So let's just write a 0, 1 knapsack to solve the problem. So I'm going to prepare going to be length of the reward values, and I want to sort it. So reward values dot sort. I'm going to sort it in increasing order, and then I'm going to use a class. I'm going to prepare a DFS. So it's going to be I and the target. Yeah. So I'm going to return DFS. I'm going to starting from the index 0, and the target is going to be 0 as well. Yeah. So now what are we going to do? We're going to check this I index. If I equal to n, definitely we're going to return the target. So the target is just the total sum. In this example, it is 11, and in the previous example, it's going to be 4. Yeah. Now, what are we going to do? We're going to have two decisions, normally for a 0, 1 knapsack. So we're going to prepare a result. So first of all, we will not take the current number. So it's going to be I plus 1, with the total number, it is t. And also, what if we can take it? So it's going to be the maximum of result with the DFS with I plus 1. And we're going to take the number. This means it's going to be t plus the reward values. It's going to be I. But there is a condition. It must meet the conditions, and then we can take it. So the condition is if reward values I is more than the current target current total values. So we're gonna choose the maximum. So result gonna be the maximum with result and DFS I plus 1, and we're gonna take the values. And finally, we're gonna return this result. Yeah, so this is a typical 0-1 knapsack, but there's only one condition we need to check. So this is just according to the problem. We are given this kind of condition. If the current I from here, if this value current I, reward value is I, is more than the current value x, more than this t is x. So we're gonna choose another way. We're gonna take this value. Now let me just run it to have a check. As you can see, it works. But there's going to be a problem because this I and this t going to be a really big value, and it cannot pass for all testing cases. Yeah, because for this I, it's going to be 2000, and also for this t, it's going to be a really big value. We don't know this t yet, but this t is going to be a really big value. Because for this t, it's going to plus a reward value I. It must meet the conditions. So for example, we have some numbers like 1, 2, 3, 4, 5, 6, 7, 8. Maybe, yeah, the number is going to be like this. So we can choose a 1 and we can choose a 2. And now we cannot choose 3, but we can choose a 4. And now we cannot choose 5, 6, 7, but we can choose 8. It's going to be something, it's going to be something like that. Yeah, and it can be many kind of different combinations. And for this t, definitely it's going to be a really big value. But there's still some conditions for this t. We can actually calculate it. Yeah, because for this t, so for example, we have a number like here. Yeah, previously we have a number like 1999, and for the next number, so this is the total sum of the previous all those numbers. And for the next number, we're gonna have a 2000. So what's gonna happen is that so this t gonna be updated to 1999 plus 2000. So it's gonna be like 3999. So this is gonna be the maximum number we can calculate for this t. And then we're gonna use this number times 2000. Yeah. But for Python, this is going to be a really big number, and it cannot pass. Normally, I think for other languages it can pass. Yeah, but for Python, yeah, we cannot pass. Let's just submit it to have a try. Yeah, now as you can see, it's going to be like memory limit exceeded. So for solving the memory exceeded problem, we're going to use our result. To restore the value of DFS with 0, 0, and we're gonna use DFS with cache clear. So we're gonna clear the cache. So this is gonna solve the memory exceeded problem. But while we are solving the memory exceeded problem, sometimes we can solve the time limit exceeded problem, but sometimes it will have another problem. It's gonna be the time limited exceeded problem. Yeah. So let me just submit it to have a check if it works. Now as you can see, still we cannot pass. Yeah, still we cannot pass, and it's gonna still be the memory exceeded problem. Although I think if I clear the cache, it should be okay, but it didn't work. Now, what are we gonna do? So there's a trick actually for this problem. And for example, if all the numbers are unique, what's gonna happen? I mean, all the numbers are unique, and the maximum length of the array is gonna be like 2000. So it's gonna be some numbers like 1, 2, 3 until like 2000. Yeah. But for this kind of cases, definitely we can choose some numbers. So for example, like 1, 2. For the next number maybe 4. For the next number maybe 8. For the next number maybe 20 or something. Yeah, or something. It is like that. But there are also some other cases like if there are duplicates. So this we can optimize in this area. Actually, it can pass. So this is also easy to yeah, optimize. So we just use the reward values. We're gonna turn it into a set, and then we just sort it, and then we can solve it. Yeah. Now let me just run it. Did I do something wrong? Yeah, let me use a list set. So this is gonna still be a list, and we can calculate the length and others. Yeah, now let me just submit it. Yeah, now you can say it can pass, at least for such cases. Maybe I don't need to use the cast clear. I can directly return this DFS. Yeah, because we used this kind of a set to optimize the problem a little bit. Now let me just submit it to have a check. Yeah, now as you can see it works, although the speed is the same, but finally it works. And there are also some optimized ways and very high advanced algorithm to solve the problem, but that's going to be the maximum total reward using operations 2. But this is one I think it is okay for us by using a 0-1 knapsack to solve the problem. Yeah, although for this problem 2, it's going to be a bit set, it's going to be a very high advanced algorithm, but I think when it comes to that problem, maybe I want to talk about it. But currently, I think it is okay for such kind of problem. Thank you for watching. See you next time.